Okay, good evening, students. Here we just discussed about algorithm. So we are going to cover basically how to represent this algorithm using flowchart and pseudocodes. And we discussed about three control structures, sequence, selection, and loops. And then we discussed about three loops, while loop, for loops, and repeat loops. And then do the past paper discussion. So these are the contents that you have to cover in algorithm lesson. First, you need to know what is an algorithm. Remember, algorithms are developed when a problem is given, we want to find the solution. So every problems you can see there will be inputs and again the output, and there will be process to solve the problem. Now this process that we are going to solve using these steps, we can write sequentially. Once you write this step sequentially, we call that as an algorithm. So as an example, very simple example to understand an algorithm, making a tea. So then what are the inputs? We know that if you want to make a tea, inputs are sugar, water and tea. Outputs what we want as a tea. Then if you want to make a tea, so you can see the steps. First of all, you have to boil the water and then put the tea in the bottom of the cup and hot water, like you can write sequentially step by steps. Now, when you write this step sequentially one by one, we call that as an algorithm. So this is a very simple example you can use to get an idea about what is an algorithm. So basically that you write the steps in sequentially. These steps should be followed from beginning to end sequentially. You can't change the order. So you have to follow the given order. That is the most important thing, because in algorithm, always we have a sequence. We have to follow the sequence. You can't change the sequence. That is what here we put 1, 2, 3, 4. Like you have to follow the sequence. This order or the sequence you can't change, because every algorithm has a sequence. So then basically you can define what is an algorithm. So algorithm define the steps that you want to follow to convert the inputs into outputs. So that is the basic definition of the algorithm. So now as an example, this is sorting algorithm. I have a set of random numbers. I want to sort them in ascending order. Then you can write the steps to sort them in ascending order. So as in this example, to sort them, how do you do it? First of all, you can get the smallest number from the input and remove that one from the input and place that in the other side. So here we have the input. What you can do is, from this input, you can now from this given input, so from this input you can do the smallest one, this one, and you can remove this and place it in other side, and go to the next, remove the next is smallest and place in the other side. Like you can see, when you continue this side, you get all the numbers in ascending order, and then you have to continue this until this side is empty. So that is an algorithm we can write to sort the numbers in ascending order. Now, why are we studying this algorithm? Remember, in computing, many places there are a lot of algorithms. Now, when you take these Windows operating systems, there are many algorithms running. When you take the data communication, there are many algorithms running. When you take the internet searching, many algorithms are running. So, like, remember, these algorithms are very important lesson. Wherever you take any application, most of the applications are working with algorithms. Then why do you need the algorithms? Remember the reasons why do you need an algorithm. When a problem is given, remember, when you're given a problem, there are many solutions you can solve the problem. But we want to find the best solution. Now, once you design the algorithm, by analyzing, you can find the best solution. So that is why we design the algorithm. Because to design the algorithm, it doesn't take much time. Quickly you can design it. And again, easily you can change it. That is the most important thing actually. Now, as an example, if you are developing a large building, first of all, you have to do the proper design through the architect, and you check whether it is suitable for the given customer. If the customer is unhappy, you can change the design which was done by the architect. But that does not make any harm. But if you take an example, if the building is constructed, a large building, at the end, if the customer is unhappy, it is very difficult to change it. Similarly, the software development also same. Once you developed, if the software is not suitable, changing is difficult. That is how you design the algorithm and check whether it is good. If it is a good, we can develop it. Otherwise, you can just forget it and go to a new one. So therefore, the reasons to design the algorithm is find the best solution, and the other one is to uh, find out whether there are any issues or problems that can be eliminated in early stages without going to the development. Then how to represent the algorithms? Remember, to represent the algorithm, there are two methods. One is a flowchart, and one is pseudocodes. In pseudocodes and flowcharts, why are we using these two methods? Because they don't have very complex syntax or rules. So that once a algorithm is developed, very easily you can make the changes. As I mentioned before, we have to make the changes. That can be done easily with the flowchart and pseudocodes. But that cannot be done in the program languages. So therefore, we use the pseudocodes and flowchart. It is very easy, everyone to understand it, and it is very easy to make some changes. So in flowcharts, we have set of symbols we need to follow, like as given here. I think you are familiar with these symbols. If you are going to make any calculation of process, rectangle, input output is a parallelogram, and this oval shape is for the starting and ending. Arrows are used to move the data here and there, and decision making or selection or repetition that will be done by this diamond shape. And connector is used to connect if the flowchart is extending to another page. Then you can connect the two flowcharts together. In pseudocodes, there is nothing actually. Everything we write in the English language, everybody can read and understand. So as an example, if you want to write an algorithm to find the area of the rectangle. So first I wrote the pseudocode where we start with the begin, and you input the length and the width, and you calculate the area. Just multiply the length and the width and output the area. Then by taking each, you can write the corresponding flowchart symbol. This is starting, this is input operation, and this is a calculation, and this output, and this is the end. So like you can use the symbols, and you can easily develop the flowchart for the given question. Now remember, whenever you take algorithm, most of the algorithms we have these control structures: sequence, selection, iteration. Remember, every algorithm has a sequence which described from beginning to end using the arrows in the flowchart that represent the sequence. So every algorithm has a sequence. But the selection or iteration or loops may be there or may not be there. Some algorithms may be there in selection or may not be there. Loops and iteration, some algorithms may be there or may not be there. Now sequence, like now if you take a very simple example, now you come to your grade 11 in a sequence. Initially grade 1, grade 2, grade 3, like you come to grade 11. So that comes in a sequence. That is what you call the sequence. So basically every algorithm has a sequence which represent by these arrows. Now this is a very simple example which has only sequence. We start, begin two numbers and do the addition or sum and output it and end. So this has the sequence, the arrow represents the sequence, which is very simple example. And this is another example how to find the area of the circle. So you input the radius, and to calculate the area we know that it is 5r squared, that is 24/7 into r radius into radius. And to find the circumference 25r, so you can use a 2 22 into 7 and into radius. So that will give you the area and the circumference. Then you can output both. Then you can write the flow chart. So you can see this flow chart has a sequence. So those are very simple example where you have only the sequence. You can see these two algorithms are not having the selection and the iteration. This has only the sequence. So every algorithm has only the sequence. But there can be some is the selection where you have to make a decision based on some condition. So then that is done with the selection. So as an example, here you can say you input the age of a person. If the age is greater than 55, you can say retired. Else means condition is not true. Then you say keep working. So in selection, remember always you have a condition. This is a condition. So this condition can be true, can be false based on this value input. Remember, if the condition is true, we execute this one. If the condition is true. If the condition false, we'll come to the else part and execute this. That is how it works. If the condition is false, you come to the else part and execute this one. So then you can draw the corresponding flow chart. So here we start. And this is the input operation. Now this is a condition. Condition you have to write with the diamond shape, this one. So in that case, the condition is true, this one, false, this one. Remember when you draw, if you want, you can put no here, yes here. You can change it, doesn't matter. But accordingly, you have to have the proper outputs. So this is how you draw the flow chart for the given selection. Always the diamond shape should be there for the selection. This is another example where once you input a number, you want to find out whether the number is even number or odd number. I think you know the mod operation in the Pascal. The mod operation will give the remainder. Now, once we input a number, we want to divide this number by 2, and we have to find out what is the remainder. So this remainder is given by this mod operation. So once you get the remainder, if the remainder is 0, then you can say no remainder means it's a even number. Otherwise, it's odd number. So we check the condition with the remainder. If it is 0, if it is true, that means n is even. If it is false, that means remainder is not 0, then n is odd number. So then you can easily draw the corresponding flow chart for this. So you can take each line. Now, first of all, you have to start and the input operation, and this is a calculation, and this is a condition. Then condition should come here. The condition is true, this one, false, this one, and finished. So that way you must be able to convert the flowcharts, pseudocodes into the flowchart and flowchart into pseudocodes. Both you should know. This is another example. If you want to check whether the number is divisible by 7, so you can calculate the remainder, use the mod operation. Once the number is divided by 7, if the remainder is 0, that means the number is divisible by 7, otherwise not divisible by 7. Like easily you can write pseudocodes for some calculation. Some instance you have to use a nested loop. That means loop inside a loop. As an example, here we input 3 numbers. What I want to do is I want to find out which one is the largest. Remember, when you have 3 numbers, you can't compare 3 numbers at once. You can compare 2 numbers. Here, what you do, we take the first 2 numbers A and B and compare them together. We know that once you compare, if the condition is true, we come to this one. Condition is true means A is largest. Then you compare A with C, third number. Where if that condition is true, that means A is the largest. If that condition is false, that means C is the largest. Then that part is over. Then you come to the else part of this one. Else part means condition is false. That means A is not larger than B. That means B is largest. So then you compare B and C, because B is larger than A. If this condition is true, B is the largest, otherwise C is the largest. So that is how we can have the nested loops, loop inside a loop. So then if you are going to the flow chart, you can see easily you can draw the flow chart. This is starting. This is the input operation or display. And this is also input operation. And this is first condition. First condition is here. If that one is true, go to second condition, this one. If that one is true, display this or display this. If the condition is false, go to this one. That means condition is false means this part. Then compare this. Once you compare that, if it is true, display this. If it is false, display this. So that way you can easily write the nested loops where you want to compare three numbers and find out which number is the largest. Now this is actually one of the past application you had. So we want to write some condition, that is to write the pseudocodes to calculate this. We know that when you take a triangle, if the angle is less than 90, we call that triangle is acute angle. But if it is angle is equal to 90, we call it a right angle. But if it is between 90 and 180, we call it as obtuse angle. If it is equal to 180, we can say straight angle. If it is between 180 and 360, we call it as a reflex angle. If it is more than 360, we call it as a full angle. So then, once the angle is input, we want to check this condition and then output the corresponding name. So then this can be done easily, either start from the bottom or start from the top. Then you can easily write the conditions as given here. So you can enter the angle alpha. Then you can say if this angle is less than 90. If the angle is less than 90, that angle is acute angle. Else means this condition is false. That means the angle is not less than 90. That means if it is not less than 90, you check whether the angle is equal to 90. If it is equal to 90, we can say right angle. And then else. Else means it is not equal to 90. Then you check whether it is less than 180. So if it is less than 180, then you can say obtuse angle. Else means angle is not less than 180. That means it's grade equal to 180. So if it is equal to 180, then you can see it's a straight angle. Else, you check whether the angle is not equal to 180. Then you check whether it is less than 133.60. Then you display this. Else, you display this. Then correspondingly, you can draw the flow chart. To calculate when the angle is given, we want to find whether it is what kind of angle. So that's a pseudocode. I will share these slides for you to study once I done it. Then this is again very famous one actually, the grading systems. Where if the marks are greater than 75, you can say A. If it is between 50 and 74, you can say B. 35 and 49, you can say C. Otherwise, it is F. So how do you write the pseudocodes for this actually? So like we did previously, what you can do is you can start with the marks either top or the bottom. You can see initially I start with the top marks. The marks are greater than 75, you can say A. But we don't validate it is more than 100 actually. If you want, you can have validation. Else means marks are not larger than 75. That means smaller than 75. Then you check whether it is larger than 50. It is less than 75, larger than 50, then it is B. Else means marks are not larger than 50. Then you check whether marks are greater than 35. The marks are greater than 35, you can say pass. Else, you can say it's fail. Same way, you can start from the bottom. The marks are less than 35, you can save. Else means larger than 35. Then you check whether it is less than 50. In that case, you can say C. Else, marks are not less than 50. It should be greater than 50. Then you have to find out whether it is less than 75. If it is less than 75, you can say B. Else, you can say A. So either you can answer from the top or the bottom. So this is another very simple example. If you have two inputs A and B, you can just compare and then find out which one is the largest. Based on the condition output, you can say A is largest, else B is largest. Then you can write the flow chart for this. However, this solution has a problem. What's the problem we have this solution? Remember, in the case where A and B are equal, in that case, this gives incorrect output. If you put A and B are equal, this condition will be false actually. If the condition is false, it says B is the largest. But we know that when the both numbers are equal, you can't say which one is largest. So therefore, you have to modify this program to check the equality. Then you will get a nested loop, like in this example. Initially, you check whether A is equal to B. If the A is equal to B, then you can say it is equal. Else means A is not equal to B. Then you check whether A is larger than B. If the A is larger than B, you can print this. Else, you can print this. So that way you can correct the previous algorithm to check the equality of the numbers. Then you can have the flow chart similarly. So we have the input operation and this condition first. Based on the condition, you can write the output. And if it is not true or false, you can come to the other condition here. And accordingly, you can produce the output. So therefore, when a question is given, you must be able to write the pseudocodes as well as you must be able to write the corresponding flow chart as given here. So this is not difficult lesson actually. Once you understood this, very easy as well as it's very important. So I think we have already discussed this one. Once the number is input, you can get the remainder. Based on the remainder value, you can say it is even number, odd number. And this one also I have explained to you, but there's a small difference, I think. Yeah, this one I have just explained to you how to write the conditions. Okay, any questions before going to the looping? Because this looping is very important. So then initially we want to understand why do you need these loops when you are writing some programs. What are the reasons we want to have these loops and what is it actually? Loop is this. If you take the example, now let's say I want to print numbers 1 to 100. So one way to do this, as shown here, one way to do this actually you can write 100 lines like this. When you write the 100 lines, you can see you can get the output 1 to 100. Then the problem is you write the same line 100 times by changing the value. So if you want to do the printing 1 to 1000, then you write 1000 lines. So if you want to print 1 to 10,000, you write it 10,000 times lines, which is very tedious task actually. But the same thing you can do with the loops that are available in the program language as shown in this example. This one for loop, I gets a value from 1 to 100. And then you print the values here by keeping this space here. That's how you get the output here, 1 to 100 easily. So in that case, if I want to output 1 to 1000, you can see only modification you need to do is this 101 should be changed to 1001. That's all. Then you print 1000 times. If you want to run 10,000 times, you have to replace this value by 10,001. So that is the advantage of the loops actually. Mainly reduce the program size and easy, and easy to make some changes actually, loops. What are the applications where we have the loops actually? What places are we using these loops? If you take this example, traffic light systems, where the same thing is conditioning is rotating again and again. In that case, you can use the loops. Another one is ATM machine. So ATM machine, you can see it is always waiting for a user to input something. So in that case, it is running with a loop actually. And most of the web servers where the websites are hosted are running always. So they are running continuously without stopping. Therefore, to implement the codes for these projects, or if you did the web server, remember we need to have the loops. These are the application of the loops. Just keep in mind. Then when you take the loops, there are three types of loops: for loop, while loop, and repeat loops. So for loop and while loop are almost same actually, similar. But the repeat loop is the one which is bit different. So in the for loop and while loop, you have a condition. This must be tested first. If a condition is true, execute this. Again, come back, check the condition. If it is true, execute this. While condition is true, executes. For loop also same. You have a condition here. Here if the condition is true, it rotates. So this will be running until that condition is false. So then you have to keep in mind the loop is running when this condition is true, exit when the condition is false. But repeat loop, remember, condition is tested at the bottom, not at the beginning. So here you can see we are testing the condition at the beginning. But here we test the condition at the bottom. So in that's the one difference actually. And here you can see if the condition is false, it will never run. But even the condition is false, the code will be executed at least once. Then only it goes to the loop here. So we'll start with the while loop. In the while loop, you have to write the word while and the condition to be tested and the body of the line, while loop and the end. So this is the normal structure. We have the basically condition, while condition is true. What happens is condition, if the condition is true, it will be executing again and again. But if the condition is false, exit. That is the one thing to keep in mind regarding the for loop and the while loop. It runs when the condition is true, exit if the condition is false. But repeat loop is the other way. So if you take very simple example, now here we have a pseudocode. You write the corresponding flow chart. So when you're going to the flow chart, you can see, you can take each line, first begin, it's here, and this processing, and this a condition. And you go here and check the condition. So if the condition is true, it executes. So then you can see it is executing while condition is true. Then to get the output, what you can do is you can create a small table like here. I have only the variable I and the condition if you want. So initially you can say I is 2, then this condition is true. If it is true, print I plus 1. Then 2 plus 1 is 3. And increment the I becomes, we increment by 2, I becomes 4. And check the condition for less than 6, condition is true. That's okay. So then you print I plus 1, that is 4 plus 1 is 5. And then increment I by 2, then I becomes 6. You can see 6 less than equal condition is true. Execute it. And then gets the next value 7. So like this, you can generate the output once the flowchart is given. Don't try to memorize. Do that thing with the understanding. That will be easier. This is another example. Where we have the while loop. First, we want to write the flowchart for this. So I just give you the few minutes. Can you draw the flowcharts and get the output of this loop? Okay, let's see how to write the flow chart. So you can start with the given steps. First of all, you have to start and input the values and the condition. This is a condition. That's what you write here. I less than or equal 10. If the condition is true, execute these lines and come back to the loop again. So if the condition is true, print I, increment s, and come back to the loop again. So this will be running until this condition is false. While condition is true, it executes. Then to determine the output, what you should do is you have to create a table including all these variables like I, S, condition. With the initial value, you have to start a loop table like this. So then you can see in this table, we have the variable I, S, and condition and outputs. So initially, I and S are 0. That's what it is set here, these two values. And then you come to the condition and check the condition. You can see initially I is 0, then this condition is true. If it is true, print I. What is the I? I is 0. That's the first output here. Then increment the I by 4. Then I becomes 0 plus 4 is 4. Then increment the S by 10. S is 0, 0 plus 10 is 10. Then again you go back and check the condition. I is how much? I is 4. Is the 4 less than 10? Yes. Condition is true. Condition is true. If the condition is true, print I. I is how much? 4. And increment I plus I, 4 plus 4, 8. Increment S, 10 plus 10, 20. And again you have to go back and check the condition. You check the I less than 10. Yes, because I is 8, 8 less than 10, condition is true. And print I is how much? 8. I is incremented by 4, 12. S is incremented by 10, 30. And you go back and check the condition. Now I is how much? 12. 12 is less than 10. No, condition false. Remember, if the condition is false, exit and go to the end of the loop. That is print S. S is how much? 30. That is how you get the output. So the program output is 04830. That is how you do it. Remember, don't try to memorize. With the understanding, do it. Create a table and trace the flow chart. Then you can easily get the output. It won't be difficult. This is another example. Just give a few minutes. Can you draw the flow chart and see whether you can find out the output? Okay, how do you write the flow charts? So initially start an input operation, and this is the condition we won't write here. If the condition is true, execute these three and come back to the loop again. If the condition is true, execute these three and come back to the loop again. If the condition false, come to this line. This is how it works. So you can create a table with the variable x, y and the condition. Initially x is 1 and then y is 0 and check the condition. You can see this condition is true because x is 1, so that this condition is true. If it is true, execute these three lines. First you increment the x by 8, then x become 9. Sorry, x become 9 and print x. So what is x? 9 will be printed. And then increment y. Y is how much initially? 0, then y becomes 10. Then once you done it, you have to come back to the loop and check. X is how much? 9. 9 is less than 20. Yes, condition is true. We increment the x, x becomes 17. Print x, 17 is printed. And again, y is increased by 10, y becomes 20. Come back here and check this. Is x less than 20? Yes, condition is true. X is increased by 8, 25. Print x, 25. Y is increased by 10, 30. And you come back and check the condition. X is how much? 25. Condition is false. Exit. Print y. Y is how much? 30. So those are the outputs you get on the flow chart. You must be able to trace this one and easily get the output by creating the table. Don't try to memorize and create the table. Through the table, get the output. So I have few more example. I will share this thing for you to study for the while loop. Then we want to come to the for loop. Remember, for the for loop, also flowchart is same actually, but the way you are writing the flow loop is different. Where we have tried the starting value and the end value. We'll take one example. So if you take this first example, y equals 1 to 10. That means I goes from 1 to 10. Output I. That means output is 1 to 10. Next one is for loop I equals 10 down to. Down to means reduced by 1. So then it goes from 10 to 1. 10, 9, 8 like that. It reduced by 1 because it is a down to. The difference is here it is going from 1 to. And this one is down to. Down to means reduced by 1. So the structure, remember the for loop will be same. But when you come to the repeat loop, it's totally different actually. In the repeat loop, remember, there are few differences. One difference is condition comes to the bottom. That's the main thing. We check the condition at the end. That is one difference. Second difference is repeat loop runs when this condition is false. When this condition false, it rotates. Whenever condition true, exit. Sorry. It is totally different from the previous algorithm. For the for loop and while loop, remember it runs when the condition is true, exit when the condition false. Sorry. In the repeat loop, remember, it runs when the condition is false, exit when the condition is true. So those are the differences. Loop condition is tested at the beginning. That's one thing. Second thing is loop will be continued when the condition is false, and loop will be terminated when the condition is true. This is the totally other way, the while loop and the for loop. And always loop body will be executed at least once. Even the condition is true or false, body will be executed at least once. This example for the repeat loop, you can see here we start, input the values and repeat, and these are the things you execute. And then you come here and execute these three lines after you check the condition. Remember, you go back to the word repeat, this point, when the condition is false. And you exit and finish the work when the condition is true. That is what you keep in mind. So if you are going to draw the flow chart, you can see flow chart structure is same, is start, input. And this is the place you have to come back. Remember the word repeat indicates you have to come back to that point. First one is print operation, then I is incremented and S is incremented. Then the condition. Remember when the condition falls, you come back. When the condition falls. When the condition is true, exit. That's what to keep in mind. Then to get the output, you can create a table like here. We have the variable I is and condition I greater than 10, 8 and output. So initially we start with I equals 1, S equals 0. And then print the I. I is how much? 1. I is incremented by 3, 1 plus 3, 4. S incremented by 100, it becomes 100. And check the condition. When you check the condition, you can see this condition becomes I is how much? 1, condition false. I is not greater than 8. Condition false mean rotate. Condition false mean you come back here. And print I becomes 4. I is incremented by 3, 7. S is incremented by 100, 200. Check the condition. 7 larger than 8, no, condition false. Then again you come back. Print I is 7. I is incremented by 310. S is incremented by 100. And check the condition. What's the condition? Sorry, print I. Sorry, we check the condition. And you check the condition, I is how much? 10, condition is true. True means exit. True means exit. Print S. S becomes the 300. This is how you get the output of the repeat loop. So then you have to remember the things. One thing is condition is the bottom. It runs when the condition false, exit when the condition is true. Okay, this one, can you draw the flow chart and get the output? Okay, how do you draw the flow charts? You can take each steps and draw it. Remember the condition is coming to the bottom. So you should get the flow chart like this. So initially input the numbers and then repeat means you have to come back to that point. That is why here the place where you have the word repeat, that's the place where you come back. And then A is included by 5 and print A, B is included by 100 and the condition. So if the condition false, here we have the condition. If the condition false, you rotate. If the condition true, exit. Then to get the output, you can create a table. In the table, you have to have the A, B, and condition and the output. So initially, A is 1, B is 10. And then A is increased by 5. So A becomes 6. And print A, 6 will be printed. And B is increased by 100. Then it will be 110. And check the condition. Now A is how much? A is 6. 6 larger than 15 false. If it is false, you know that. If it is false, you come back. Increment the A becomes 11. Print A print A is A6, 11. B is incremented by 100, 210. Check the condition. Now when you check the condition, A is how much? 11, 11 larger than 15, no false. If it is false, you come back here and increment the A becomes 16. Print A, 16. B is incremented by 100. Check the condition. What's the condition now? A 16 larger 15. Yes, condition is true. If the condition is true, exit. And print B. B is how much? 310. So that will be the output. 6, 11, 16, and 310. So that way you can easily get the output. Don't try to memorize the thing. With the understanding, do it. This is one of the passive example, or passive application actually. So you can create a table. You start with the so you can like create the table and then you will see that output becomes -1. So here the inputs are given. So actually you can create the table. You can trace like we did previously. Then you get the output. This is the for loop. Now we want to study the for loop also. Remember, there are few things you need to understand when you're converting the for loop into the flow charts. The things you should know here is actually in the for loop in this place, you don't see the termination condition actually. You have to create it. What is the termination condition? Initial value I is 1. So we have to have this I is 1. So that is what we have here. I is 1. And the termination condition is I less than or equal 5. That you have to identify. It is not given here. So that is what you should have inside the condition. What is the condition? I start from 1 to 5. So when it is 5, it should be stopped. Therefore, the condition is I less than or equal 5. And then increment this variable value and print this. Other thing you have to know is here actually, I will be incremented by 1. So that is also not shown here. I equals I plus 1. It's not there, so you have to write it here actually. So then you can see there are few things when you're converting the pseudocode into flowchart. What are the things? First thing is starting value. Here you have to identify starting value. That's what you have to indicate here. I think it's a condition. This condition is not given. You have to find out the condition. It goes from 1 to 5. Then the condition is I less than equal 5. The last one is the incrementation. I should be incremented by 1. So that's what you write here. This is also not given. This is also not given. So you have to identify those two. Other tasks are same. Like tracing this one and create the table, get the output will be same as the others. But drawing the flowchart is the very important thing. Okay, this one, can you draw the flowchart? Now, in this one, remember when you go to the flow chart, what are things you have to identify? Starting value, that is this one, b equals 6. And termination condition is b less than or equal 8. That's the termination condition. Starting value, b equals 6. Termination condition, b less than or equal 8 is not there. And the b incremented. So you have to increment the b by 1. B equals b plus 1. It's not there. So we have to have the b equals b plus 1. It's not there. So these things you have to identify. And starting value. When you're drawing that, you need to have that whatever the starting value, termination condition b less than or equal 8, and incrementation b equals b plus 1. Those are necessary actually. So then when you draw the flow charts, you should get the flow chart like this. Starting value b equals 6, termination condition b less than or equal 8, and then increment this value, print the value, and the other one b equals b plus 1 incrementation. This is not given. You have to write those two. So then you have to carefully identify starting value b equals 6, termination condition, incrementation. That should be done here. Other steps are same. That is, drawing the table and getting the output are same as the others. So those are the 3 loops actually you should know. And this is another example. Again, you can see starting value s equal 10. Termination condition is less than or equal 12. And s should be increased by 1. S equal s plus 1. So that's what you have to have. So you can see starting value s equal 10. Termination condition is less than or equal 12. And incrementation of this x equal s plus 1. So those are the values you need to have. The other processes are same like we discussed in the other algorithm. So once you make this condition always true, always false, you get infinite loop, the loop which is never ending. So when you take this condition, if the condition is always true in a for loop and while loop, if the condition is false in repeat loop, it runs continuously without stopping. Then we call that's an infinite loop, a loop never ending loops. So these are few more examples with while loop and for loop. I'll share these notes, you can study them actually. Few examples are there. This is actually one of the past paper question. They gave this one and asked to draw the flow chart. I think it's very easy. Start, get the inputs A and B, and check the condition A greater than B. If the condition is true, display A. If the condition false, display B, and out end or stop. So this is the example of one of the past paper question actually. This is another past application they have given for you to draw the flow chart. So you can see n start by 0 and while condition is there and get the inputs. And you can see inside there's another condition, that is number of days are less equal to 210. If the condition is true, print admission number, otherwise nothing to do, and n should be incremented. So that way, when you are given pseudocode, you should be able to write the corresponding flow charts like this. This is not a pass application, but if you look at this, you need to identify things actually here. Starting value and the input operation, and this is setting the value, and this is a condition. Remember, if the condition is true, this one, the condition false, this one. So if the condition is there, if it is true, we set this value. If it is false, you can see if it is false, you come to a loop actually. If it is false, you come to a loop. It's a while loop. And while n is not equal to 0, you execute this one. So that way you need to identify the condition. Now you can see this condition is not a loop, but this condition is a loop. Like you to identify it clearly. This is another example. You can see we start here, input the value, and these are some settings. And this is a loop. You can see it's rotating. It's a loop. Therefore, use a while here. And after finishing, you come here. That means after in the while, you come here. If it is true, this one. If it is false, this one. It's a selection. It's a selection. If the condition is true, this one. The condition false, this one. It's a selection. Like you have to identify which one is loop and which one is a selection. This is again, which is there in the textbook actually. So you can draw the flow chart corresponding to that. Now this one is actually to find the minimum number. So you input the 10 numbers here. First number here. You take that number as a minimum and then take the next inputs and compare with that. The next input number you compare with minimum number you have set as a first number. Like this algorithm is actually to find the minimum value. No need to memorize, just keep in mind. Now this is one of the past application. I just give you a few minutes. Can you try out there? Okay, this one, we want to count 1 to 10. So sum is the one which will add this number. The sum is start with 1 and that number is added to the variable sum. This number is added to the variable now. Now here we have to increment the number because number is start by 1, but number is not incrementing. So therefore you need to have a line number equals number plus 1. This one should be there. Because otherwise it will be infinite loop. Sorry, it will be just execute only once. Then next one is consider the following pseudocode. How many times this will be executed? Now again you have to create a kind of table. So here we have variable p start with 0, sorry, and condition p less than 6. Then you can see we start with this, check the condition p less than 6, p0 condition is true. True means execute this one first time and p is incremented by 3. Then p becomes 3. And come back here, check the condition. Is the 3 less than 6? Yes, condition is true. Execute this second time. P is incremented by 3, then it becomes 6. And come back here, check the condition. 6 less than 6. Remember 6 less than 6. Condition is false. Exit. Therefore, this will be executed twice. Answer is this one, twice. So that way you can get the answer easily. Okay, this one, consider the following pseudocode fragment. Which of the following is true? Now what you do here, we check the weakness. If the weakness is less than 40, as well as character is greater than 70, then you can say good. So what you do, you check weakness is less than 40. So this is wrong because you have to check the weakness. We check whether weakness is less than 40 and operation because you check this one as well as this one. So therefore answer is third one because you go inside the condition. Okay, this again, yeah. Okay, try these questions. So in this question, they have mentioned that 3 is given as input. So therefore here n is equal to 3. Then x is 1. So you come here, you check the n is 3. The 3 is equal to 1. No means you come to this side. X equal x into n. X is how much? 1. N is how much? 3. So then x becomes 3. N is reduced by 1, n becomes 2. Then you come back here. Is the 2 equal to 1? No. Then x equal x into n. X is how much? 3. N is how much? 2. So 3 into 2, 6. Reduced by 1, n becomes 1. You come here, check the condition. Is the n equal 1? Yes. Print x. X is how much? 6. Therefore, answer is 6. Which of the following constructs are best suited to be included in the computer program based on the flowcharts? So this actually doesn't have a selection. This is only the while and in while actually. No only selection. Only loop is there actually. You can do with the loop. See only. But it should be a repeat loop actually. But while loop also can be converted to repeat loop, no matter. Definitely loop should be there. In this algorithm, n always has to be a positive integer. Yes, it is correct, because if the n is a negative integer, what happen? This condition will not be satisfied because we reduce the n by 1. Which of the following is recommended for the flowchart to fulfill this above condition? Keeping the flowchart as it is, changing n equals 1, condition n equals 0, and change the n equals 1 and condition n equals -1. And check in the value of the n immediately after as it is input and stopping it. Yes. Yeah, if it is a negative number, what you do is once you say enter this, we have to check whether it is negative, and then we have to terminate it. Otherwise, it won't be terminated. It runs an event in loop. This is again pacification. Can you try out to write the pseudocode? Okay, if you look at this question, it says that students can go to school either by bicycle, school van, or bus. It can be chosen based on the total distance as follows. Now they have given the conditions actually. If the total distance is less than or equal to 5, use the bicycle. And when the total distance is more than 5 kilometers but less than or equal to 15 kilometers, if the distance from home to nearest bus stop is less than 1 kilometer, use the bus, otherwise use the school van. And when the total distance is greater than 15, if the monthly van fare is less than twice the monthly bus fare, then use the school van, otherwise use the bus. Now, based on that, you are asked to write the pseudocodes with the given inputs. So, how do you write it actually? Now, we can look at the condition carefully and then you write it actually. So, if you look at the total distance, which is represented by TD, total distance here, total distance is represented by TD here, this one, and the bus stop distance is D, monthly van fare is VF, bus fare is BF. Now, these are the variables that you use to write the pseudocodes. So, we can write the pseudocodes actually. We have to have the conditions. We can take the notepad. I just write the report to the notepad. So they have mentioned the conditions here. As you can see, we can start begin and then check the condition actually. You have to input. We need to input basically total distance TD and we have to input the D, BF and BF. D distance to the school, vehicle, van fare and bus fare. Those are the inputs. We have to check whether if total distance. So if they mention that if the total distance are less than 5 kilometers, if the total distance are less than or equal to 5 kilometers, then you can write according that is use the bicycle. So that's the first thing actually. When the total distance is less than or equal to 5 kilometers, use the bicycle. Then else if means if the distance are more than 5 kilometers and less than 15 kilometers, then you can write else ED less than or equal 15 kilometers. Then we have to check another condition actually in that case. If the distance from the home to nearest bus stop is less than 1 kilometers, use the bus, otherwise use the school. So that means if distance D less than 1, then what it says, if the total distance is school from home to nearest bus stop is less than 1, then use the bus. Then you have to say use the bus. Else use the school van. Then there's another, there should be another else part actually. Else, yeah, we have to have the else part. Under that, we have a condition. Else means distance are greater than 15 kilometers. And then you have to have another condition saying that if the van fare, if the monthly van fare less than the 2 times the monthly bus fare, use the school van. That means if the van fare less than twice the bus fare. In that case, it says that use the school van. Else, use the bus. Then you have to finish it. And if it's on, and if, and finish the program end. This is how you should write it actually. Here input the each variable. If the distance is less than or equal to 5 kilometers, use the bicycle. Else if distance is less than or equal to 15 kilometers, and use the bus else. And here there should be a MD here actually for this one. This is how you should write the pseudocode for this question. That's what they have asked actually. Then the next one, how many times will the statement count equals count minus 3 will be executed? So again, you can use the starting value 12. You can create the table. So count is 12. You check this one. Condition is true. 12 is larger than or equal to 3. Yes, this will be executed. Count will be reduced by 3. Then count becomes 9. You have the 9 and 9 is larger than or equal to 3. Yes, executed. And reduced by 3, then it becomes 6. It is 6 larger than 3, executed. Then you go back here, reduced by 3, that means it is 3. 3 larger than or equal to 3, executed. That means 4 times. So the next time it becomes 0. It will execute 4 times. Then the next one, the following algorithm is used to select the players for the rugby pool. The selection is done based on the height, weight, and the age of the player. That means you check whether the age is larger than 21 and height is 160 or weight is greater than 70. Based on that, you will qualify, otherwise not qualify. So when you take these children, one thing is age should be greater than 21. So therefore, all three are okay based on the age actually, because age is satisfied. Age is larger than equal to 25. Then the other one of the condition, either height. Now you can see this one, height is not satisfied, but weight is satisfying. Then it is okay, because one of them is this one or this other one, or operation. Therefore, he is qualified. Now here, this one height is 160. That means he also qualified. Sorry, he also qualified. But when it's come to this one, therefore both are not satisfying actually. This one or this one, both are not satisfying. This condition and this condition. Therefore, he's not qualified. Other two are qualified. So that's how you have to do this. So this is not difficult actually. Try to go through some other past papers also. Then this is not difficult, easy lesson. And once you understood this, next you have to do the Pascal thing actually, how to convert this into Pascal programs. So next seminar I'm planning to have on next Friday or Saturday. I will let you know. There I will discuss the Pascal programming related to this. Are there any questions you want to ask? Okay, if not, we'll stop here. Thank you for joining. Then next time, next Saturday or next Friday, I'll inform you. I will discuss the Pascal programming part. Thank you for joining.